Okay, this is the Unit 2 test corrections for the MCQ. Number 1, it gives you diagram force going this way, then giving mass A, B, and C. I'm going to ask how will the normal force change on blocks A and B and C if this mass is moved to the top there. Okay, so if you move this mass here, and B will be the same because the normal force on A will still be the same on B because the mass of A will be the same. So force A on B, same, and then if you move this on top to C, then the normal force on C will be greater on B. So that means the force of B on C will increase. Okay, next question I got wrong was number 4. This one, if the block is sliding down the incline like this, gravity is pushing down this way. So force of gravity is right here. The only part of gravity that is going to be moving the block down this way is going to be like only a percent of it, like only this portion. Let's just say that's a 30-degree angle. It'll only be that portion of it is pushing it down this way. The rest of it is just going to be translating it and keeping it down on the ground. So that's why this way will be slower than if you would just drop have an object fall off from free fall, because gravity is being used to push the object down on the incline as well as moving it down the incline. So the total force of gravity isn't being used to push the box down this way. Okay, number 5, the canoe question. So this one, simple force equals mass times acceleration. You're assuming that there's no friction in the water, no friction between your shoes and stuff. And since the canoe weighs less than you, let's just draw this. So you're applying a force this way, and since the canoe weighs less than you on the water, it's going to have the same force moving this way by one of Newton's laws. Every action has an equal and opposite reaction. So since the canoe has a smaller mass, then it'll move in the opposite direction. In this case, is left faster than you are moving to the right. Okay. Number 6. Box of ass M reduce from rest and acceleration on a ramp. Does any angle theta? How are the magnitudes of the horizontal and vertical components of the box's velocity changing, if at all? Okay, so box is sliding down the ramp. So it's moving up and down, obviously, because it's on an incline, so it's going to be moving down as well as to the side in order for it to go here. So it's going to have horizontal and vertical components in the box's velocity. It's going to be falling down and to the right in this equation, or in this question. Okay. Number 8. Okay, so this question, what I got wrong was I chose option B instead of option A. Option B, I chose that because I assumed that the center of mass was perfectly in the middle in this grid. I'll just draw it out real quick. So it's that thing, bigger mass 2m. Okay, in this question, I chose option B. The velocity of the center of mass of the two-block system is directed toward the right, because I thought that the center of mass would be here, and if this object was moved further to the right this way, or if this object was moved further to the right this way, then the center of mass would shift over this way so that it would sort of balance it out. But the center of mass in this problem is already done, I guess is a way of saying it. So it's already over here. It's not in the middle, which is what I assumed earlier. So when they separate, it's just going to stay in the middle because they both they already separate at not at the same distance, but the center of masses will stay the same. And that's option A, that the velocity of the center mass of the two-block system is 0, which is, what this is. Yeah, that's it.